Some of you may have seen my other video, but I'm going to go ahead and take it from the top. This is a SGI Altix 450. It's marketed as a server or even a off-the-shelf supercomputer. This particular machine uses Itanium 2 dual-core CPUs. Each 5U rack chassis has 4 slots for CPU node boards and 1 double-width slot for an I/O expansion bay. There are 2 1300 watt power supplies, and there are 4 NumaLink ports per 5U rack chassis. With these NumaLink ports, you can hook multiple 5U rack chassis together, as I have done with a pair of these, for a single system image, or basically these two collectively function as one giant computer. So let's kind of go over the configuration of this, and then I'll show you how the power on sequence and everything else. So basically, what we're looking at, we'll start with the bottom one. Now you'll notice on the display that says 001C01, and then this one says 001C02. L1 is equivalent to like the lights out management that you see on compact servers, and it's also kind of like a BIOS, but this doesn't actually have a BIOS. It uses EFI, just like all new machines, new Macintoshes, etc. So the bottom one here, we have DVD burner, 2 SATA ports, or slots I should say, serial attached SCSI, and then we have a 4X serial attached SCSI here. We have 4 USB 2.0, 2 gigabit Ethernet, and 2 half-height PCI-X slots, which in this case has another dual Ethernet, gigabit Ethernet, and another serial attached SCSI. In our particular configuration, I have Ethernet port 0 for my Linux network interface. And you'll notice that over on the L1s, or where the L1 display is, there's another network port, and it's labeled Cat6. This is for controlling the system power on and power down. It is imperative that you have all the L1s linked together if you are linking them via NumaLink. The systems will run off one power supply, but on one of the systems I do have both plugged in. Only really needed one for this one. The I/O card cage on the top system actually is just 4 full height card slots. There are 2 PCI-X slots and 2 PCI Express slots. This quad gigabit Ethernet is occupying one of the PCI Express, and you can actually get a video card that goes in here, the ATI Fire GL. I don't think you can just throw any old video card in here, because I did try an NVIDIA graphics card and it didn't like that very much. The system actually hung. We get 2 power ports back there. I believe those are the same 6-pin power on these higher end graphics cards that you see. So I think the system can be configured pretty wildly to do graphics. And then there's the bus connectors. And each of these slide in here just like this. And then you seat it. Then you push this tab in until it locks. You're all set. So let's take a look at one of the CPU boards. Basically the same thing. Pulls out. Pull this little tab on the bottom. And that's the back side or the bottom. And then this is the top side of the board. Each one has 8 gigs of RAM. 8 1 gig sticks. And there's 2 separate memory banks. They label them right and left. Here you can kind of see on this. Let me get a better view of this for you. Up here I have another Itanium CPU board, and whenever I boot up with this board inserted, it says that the RAM in bank 0 can't be found. So if I move the RAM to the second set of slots, it does come up, but then the kernel actually crashes, so I don't know quite what's going on with that. But you have 12 RAM slots in total, and you have 2 Itanium 2 CPUs. All the CPUs are dual core. They are 1.6 gigahertz with a 533 front side bus, 18 megs of level 3 cache. C2 I believe would be the stepping, and SL9P8 I believe is the CPU's part number. Each CPU is used in conjunction with the voltage regulator here, and this voltage regulator input 12 volts DC, 11 amps. Output, let's see, looks like there's 3 outputs, 0.8 to 1.3 volts at 85 amps. Output 2 is the same at 17 amps. And output 3 is 1.25 volts at 9 amps. This heatsink chip here is what you could kind of think of as a chipset. It's actually an ASIC, and in this case it is an 8-way crossbar, meaning that 8 things can communicate simultaneously across the same chip. So this CPU could be talking to this RAM, while this CPU talks to memory in another node board, while this memory talks to a CPU in another node board, or this could be talking to disk, and so on. There's a couple of small voltage regulators on these boards. Each CPU has its own power connector, 6-pin power connector, just like that. And that's pretty much it. Same bus plugs as the I/O boards. Everything communicates using the same standard protocols. Actually, I kind of wonder if I could take one of these and stick it in that double width slot and it'd recognize it as a CPU. I might try that one day. Okay, so in case you were wondering what an Itanium CPU looks like, this is what's underneath all that metal. Just wow. There's a lot here. Now, from here forward, this is all power regulation. And then from here back, this is the processor board. There's no external cache. It all appears to be on the die. And here's our 6-pin power connector for 12 volts. And here's our, it says MPGA 700, so 700 pin, I would assume. That uses an Allen head to actually get the socket loose. If you need to remove one of these processors, there are 6 screws. 1, 2, 3 is right here. 4 is right here. 5 is right here. 6 is right here. Under no circumstances do you need to remove these 2 to get the CPU unit out, but if you want to separate the power regulation from the processor itself, you will need to undo those 2 screws. I don't feel the need to do that at this time because the 2 processors, I believe, are actually still good. I think the issue with this particular node board is not necessarily an electrical one, but maybe more so that it's the incorrect firmware revision. All the firmware on the other 6 node boards are a year newer, and this was the previous year's model, so I think that has something to do with it. And I'll research and try to see if I can upgrade or what have you. But yeah, there's a look at an Altix 450 node board. This is what one of the power supplies looks like. It is 1325 watts. It'll output 83 amps on one 12 volt rail, 100 amps on another 12 volt rail, and 7.6 on a 3.3 volt rail. There's no fans on the ends, they're actually in the middle, which I thought was kind of interesting. Here's one that's actually bad, has a capacitor issue. So now you can take a look inside. That's the connector end. Output regulation. Fans. input filtering, main power stage. Very, very well packed in there, I must say. Interesting power supply. Moving to the back of the system, we have 3 fans, 3 blowers per 5U rack cabinet. And interestingly enough, you can separate them here. So if you wanted to build your own cooling unit that had radiators or maybe even water cooling or something like that, it doesn't seem like it's too complicated. Each blower is pretty much the size of my hand. I have a pretty big hand, so they're fairly quiet. I actually could probably leave this system running and still sleep in here at night with the fans on low, although if the system gets hot, if it gets above 85 degrees ambient air temperature, these fans do start picking up in speed and noise. Oh yeah, I guess I could show you. In here, you have your fan connector, of course, and then a door that will actually come closed from the suction air from any remaining blowers. So if we have a failure here, that door would close and air would still get drawn across all those components inside the cabinet. And to put them in, you don't put it in upside down. They're a little tricky, but I basically keep the bottom plate against the backing and then give it a little slam, and then the connector seats, and we're good to go. Normally don't bang around parts like that, but you kind of have to with those. And then I guess all that's really left is the NumaLink ports themselves. There are 4 ports per 5U cabinet, 2 on this side, 2 on this side, which means 1 router board for every 2 ports. And how you connect these up is top to top, bottom to bottom. And I just kind of have these weaved together so they look nice sitting up here. That pretty much covers it. On a system like this, let's say you had more than 2, you could link these 2 together like this, and then on this side, this set could go to the next rack unit up, and this set can go to the next rack unit down. Or in this case, if you have just the 2, you could use 4 of these cables and then link the 2 together for more system bus throughput. The cable, I do have a 3rd cable, I do not have a 4th. If I keep the system, I'll get a 4th. Other than that, the only other thing to really point out is these blank CPU card slots have plastic in the middle to block the airflow. So if you're missing these, you're going to need to put something in the slot so the airflow is evenly distributed amongst the remaining cards. And I have a couple of spare parts here that we can take a quick look at. This is an L1 controller board. This one's actually bad. I'm not sure why. The clock battery seems to check out fairly okay, like 2.5 volts. I'm not sure what the threshold would be for the cutoff, but 2.5 should still hold some type of memory. There's basically 1 ribbon cable and a little Cat6 port that goes to the Cat6 up front, and then this ribbon cable is underneath this metal shielding here. It pops out right here and goes to the display port, the reset button, and our console port. Now, I don't actually have a console cable to set these up, and if you're in the same kind of boat, do not fret. There is a way that you could do this. It's the same way I've set up other systems in the past, and that is take your laptop, plug it into the Cat6 port, fire up Wireshark, packet sniffing software, and then after your packet sniffer's up and capturing, go ahead and plug the system in so the L1 comes online, and it'll start sending out packets. Even if you're not on the same subnet, the packet sniffing software picks it up, and all you have to do is look at the originating IP address from the L1 controller, and that'll tell you what IP address you need to telnet to. So you just set your network adapter to the same, Class C IP address and subnet, and then telnet on over, and you can start messing around with your system setup. Here's one of the router boards. You can see the two NumaLink ports on the end. Big processor in the middle there, and some supporting circuitry. Looks like a small voltage regulator, and a giant, it's got to be 1,000 pin header on the connector end of it. So lots of data goes through there. Okay, so now that we've went over how all this is basically set up, we're going to go ahead and boot it. Now what I'm going to do is I'm going to have a screen capture so you can actually look at the boot process in extreme detail. But here's how you power it up. With your L2 prompt, PWR U, and then hit enter. Turn this off. Green lights basically indicate power. I think there is one red one in between where the green ones are illuminated. That would indicate bad power, supply power. And then the orange LEDs that you're seeing are actual heartbeat LEDs. Now even though there's only 2 physical processors, there's 4 cores, so they supply 1 heartbeat for each core. And then over here on the system status, it'll tell you initializing memory, or initializing communications, etc. And there we go. We're up and running. Now I don't actually have a drive sled for my SATA drive, so I just kind of set it in there and gave it a little foam spacer so it sat in there evenly. Don't know if you can see the activity LED. But it is booting.
comes the fun part. Here comes the fun part.